Hello everyone, welcome in the name of Saint-Gobain Technical Insulation to our webinar. Our topic today is HVAC acoustics, or more precisely, reduced duct noise with insulation. Before we start, I would like to say a few words about Saint-Gobain Technical Insulation. We can talk about our activity in terms of technical insulation markets. Since 1937, we have been providing sustainable insulation solutions to different technical markets such as industry, marine and offshore, HVAC, and OEM. We are present worldwide through our two international brands, Isover and CLIMAVER, and a network of local brands. Our strength is that we are not only global, but we are also local, because we have a lot of local teams, local production sites in many parts, in many regions of the world. We are experts in an array of insulation materials. It starts with mineral wool, such as glass wool and stone wool, which are mainly used for warm applications, above ambient temperature applications. This can go up to 700 degrees. And we also propose elastomeric foam insulation, which is used for cold applications, for applications below ambient temperature, where there is a risk of condensation. But let's come to the topic of the day, HVAC acoustics, reducing duct noise with insulation. The webinar will be organized in 4 parts. The first one will be about some basics of HVAC acoustics. So we're going to see a few theoretical notions of acoustics, and specifically in building and in HVAC. The second part will be dedicated to our solutions, to different insulation solutions that are available to reduce noise from and in ductwork. Then there will be a short conclusion, and at the end of the webinar, we're going to dedicate at least 15 minutes to answer your questions. How to raise your questions? You see on the top right of your screen a little icon, which is the question Q&A icon, where you can just click and answer your and raise your questions. You can ask your questions during the webinar. You can already start if you have already questions in mind, and you can do it also at the end. We're going to take time at the end of the webinar to address them. Now let me introduce our expert speakers. We are very lucky to have 3 fantastic experts with us today. One, Gary, who is our acoustic expert. Gary holds a master's degree in physics and a PhD in building acoustics. He has been working at Saint-Gobain Research in the Parisian Research and Development Center as an acoustic expert dedicated to insulation, to building insulation and technical insulation. And then we have 2 HVAC experts. Elodie is the HVAC product manager at Isover France. Elodie is a chemical engineer who has extensive experience in R&D, in product management, and now since 5 years in the field of HVAC. And finally, Guillermo, PERTIERRA, who is also a chemical engineer who started his career as a technician in quality, environment, safety, and health, and who is now part of the business unit Saint-Gobain Technical Insulation as our CLIMAVER specialist. So Gary is going to start. I will leave the floor to him. Gary, the floor is yours.
Thank you, Enrique. And hello, everyone. So we are very pleased to be with you for this acoustical webinar on HVAC. So as Enrique told you, I'm going to give you some basics of HVAC acoustics and acoustics in more general terms, I would say. So maybe I will start with some general facts, which can be quite obvious, I guess, for you. That let's start by telling that noise can affect our well-being and comfort in buildings. So, for example, noise lowers our efficiency during our daily tasks. It produces adverse health effects, and it can also cause permanent stress and in concentration and communication, I would say. I will continue a little bit to give you some general concepts and work we did in the past at Saint-Gobain. So we worked quite a lot in the past to define some kind of multi-comfort classes in buildings. So we worked a lot to develop for different sensorial comfort criteria such as thermal comfort, visual comfort, acoustical comfort, and also indoor air quality. We try to define different ratings able to reproduce the comfort in different case studies. And all this to tell you that noise control in building is key to ensure the final user comfort. So let us start with the very basics of the sound. So what is a sound? Just keep in mind that a sound is a vibration propagating in any elastic medium, which can be a fluid or a solid. But it's key to keep in mind that if you do not have a supporting medium, you don't have any sound wave. Because if you do not have any medium, you don't have any molecules able to vibrate around their equilibrium. So in very general terms, you can describe any sound by what I will call the sound pressure level in decibel scale, you will see, and the frequency of the sound. So basically, you can see on this equation, which are quite basic, that you can define the wavelength of the sound by the speed of the sound in the medium divided by its frequency. So typically, the wavelength will be the distance between two maximum of the oscillation. So the wavelength will be in meter, the speed of sound in meter per second, and the frequency in hertz. On the other side, on the right, you have another expression giving you the expression of the sound pressure level in decibel, so in logarithmic scale of the pressure, simply given by the pressure of the sound divided by the threshold of hearing in air, which is simply 20 micropascal. So I will just take a few more minutes to explain you a little bit more what is a frequency, because as you will see during our speech today, the frequency of the sound is really an important parameter to bear in mind to solve your acoustical issue in practice. So as I told you, the frequency of the sound is typically the distance between the two maximum of the oscillation. So typically, when we want to have in mind a low frequency source, you can have in mind a drum. Typically, the sound produced by a drum will be in the quite low frequency range, let's say around a few hundred hertz. And on the other side of the spectrum, you can imagine the sound produced by a whistle, and this spectrum will be more in the few thousand hertz. So this is just to give you a few practical examples. So now if we come into more details around the typical noise sources we have to address in buildings, you will see that it is quite wide band. Let's say it can range from 50 hertz to 10 kilohertz, so it's quite open in terms of sources. It can be very different. So it's quite a challenge actually for us, because as you will see, we have to provide you a solution able to absorb or insulate the low, the medium, but also the high frequency. Just a last word, just to remind you, for people who are not very familiar with acoustics, sometimes you can be mistaken between the pitch of the sound and the level of the sound. So when I will talk about the pitch, it will always refer to the frequency of the sound, while the sound level will refer to the amplitude of the oscillation. Now I'm going to give you a few words regarding the loudness perception by human being. And actually it's quite important to have this in mind to understand why acousticians in practice not only speak about decibel, but they generally introduce a weighting function to include human perception. Actually, when you have a look to the threshold of hearing of sound by human hearing, you can see that our ear is less sensitive to the low frequency, and it is more sensitive around 2 or 3 kilohertz. So for example, if you have a look to the graph on the left, you can see that around 20 hertz, to be able to perceive a sound, you need to speak with a level around 80 decibel, while at 2 or 3 kilohertz, the threshold of hearing is around 0 decibel. And actually, from this threshold of hearing curve, you can derive another curve, which is given on the right, which is called the A weighting curve, which is very important in practice to consider sound level in decibel, but in dBA, which really includes human perception. Before entering into into the detail of HVAC acoustic, I think it's quite important to have this in mind, the logarithmic scale, but also the fact that human hearing is more sensitive to medium and high frequency, because in practice, you can be faced with different technical data sheet of product, for example, in terms of sound insulation, and quite often it can be tricky to compare product between them. And so when you will ask yourself, okay, I have a system A with, for example, a global insulation of 20 dB compared to another product with a global insulation of 22 dB, the question which can be raised is, okay, is it significant or not? And to answer this actually quite complex question, I would say keep in mind a threshold for perception which is of at least 3 dB variation between product performances. Below this threshold, it will be quite difficult to make the difference between different products. And actually, this topic is something we address at Saint-Gobain. It is the field of psychoacoustics. So now I'm going to give you a few words of our typical noisy sources which we will have to control in practice, so in buildings, I would say. So as you can imagine, we can be faced to impact noise sources, such as footsteps due to neighbors. But you can also imagine some kind of exterior noises due to transport, airplanes or car or whatever. You can also be exposed to interior noises due to music, conversation, and so on. And on the right, you have the menu for today, which is the HVAC acoustical issues we have, which are, I would say, more due to equipment noises. So you can think about washing machines, pipes, elevators, and of course, ductwork systems. So let's continue with some general features of HVAC sound sources. So you can see on this graph that it's quite interesting but quite complex because we have to tackle many sources in different frequency ranges. So for example, in low frequency, typically from 50 to 500 Hertz, you have typically the fan and pump noises, which are a first issue we have to solve. But you can also get in the medium and high frequency, typically from 120 to 2 kilohertz, some VAV unit noises. You can also be faced to centrifugal chillers in the range of 250 to 1 kilohertz. So quite interesting, but quite challenging for us because, as I told you, we have to provide solution able to do the job in a very wide frequency range. And also this is quite challenging because I explained you a little bit the notion, the concept of wavelengths. And for example, in low frequency, the wavelength is very big. For example, at 100 Hertz, the wavelength is in air is around 3 meters. And so our acoustical solution of generally a few centimeters are not so efficient in this frequency range. So it's always a big challenge to address this diversity of frequency ranges. So now if we still come a little bit more in the detail of a typical ductwork, so imagine that we are building a ductwork system and we are asking ourselves, where is the noise coming from? So on the left you have, we start from the beginning, so the fan noise, for example, which is our typical sources in this field. The first acoustic topic we can be faced is what I call structure vibration, which is simply due to the fact that some part of the duct vibration can be transmitted to surrounding system, which can be floors or walls. And this is what I call flanking transmission, which can be negligible in practice if the duct is correctly decoupled from its environment. And on the right, you will have our big part of the job for today, which is the duct vibration. So imagine that inside the duct you have an airflow generally. This airflow can generate vibration of the ductwork, and this vibration can be transmitted to the air, to the external surrounding medium. This is what I will call, in all the presentation, the sound insulation topic. And you will see we have plenty of solutions able to address this part. And the last part of the job, I would say, is the sound due to opening radiation. So imagine that you have at the beginning the ductwork with the sources. The sound is able to propagate inside the duct, and when you have opening radiation, you will have some sound radiated by this opening. This is what I will call the linear attenuation topic. And in the next of the presentation, I will focus myself more on the sound insulation and linear attenuation criteria. So before entering into the details of linear attenuation and sound insulation, I will just give you a few words of sound insulation and sound absorption, because sometimes, from my little experience, for people who are not very familiar with acoustics, sometimes it can be a little bit tricky to make the difference between these two topics. So we are still talking about acoustics, but when I will talk about sound absorption, what does it mean? It will mean improving the sound quality in the same volume of the sound sources. So imagine that you have a room acoustic problem, and to solve this problem, you will typically use absorbing material able to reduce the sound level, improve the speech clarity of your discussion, for example. And another topic we have is what I call the sound insulation, but in this case, the acoustical objective is really to reduce the sound transmitted by the structure to surrounding volumes. And depending on the objective, you will not use the same material. So just to give you a practical idea, in building, we have lots of facades made of double glazing units, for example. In this case, there is no absorbing material, but yet the system is very efficient to insulate from the outside to the inside. So we have a very good system in insulation. However, we will have some issues to absorb the sound, because the glass typically is doesn't have an open cell microstructure. Okay. So on the other hand, when you will have an issue related to sound absorption, typically it's not mandatory, but more often you will use some kind of open cell material such as mineral wool. So I would say, but we will insist with Elodie later on this, maybe as a first step, it's very critical for you to clearly identify what is your need in terms of acoustics. And this is especially relevant for HVAC because, as I told you, but we will see in more detail, you can be faced to both problems in acoustics. Absorption with linear attenuation and sound insulation of the duct. So the first acoustic challenge we have to address with ductwork system, the first challenge is to be able to mitigate the sound radiated outside the duct walls. So the key property, the key rating to address this issue is the sound insulation criteria. And from our experience, this is a topic quite often neglected in practice, but yet it is quite relevant. Why? Because the first point is that the sound insulation of a ductwork is generally quite poor, especially in low frequency. So you have an example, a curve on the right, giving you the sound pressure level measured for different duct section, metallic duct section, from 300 to 600 by 400 square millimeters. So the sound level radiated versus frequency. And what you can observe is that typically from 50 to 500 hertz, the sound level is very high. And this means that the sound insulation of rectangular ductwork is very low in low frequency. So it can be the weak point in practice. And the second point is that the ductwork can be the weak point even if you have a false ceiling. Why? Because, for example, if you imagine to get a false ceiling which is perforated, for example, in this case the ceiling will not be able to insulate, and so the weak point can be the system just behind the false ceiling, which is the ductwork itself. So I took some pictures from my daily life experience just to show you what we are talking about. So on the picture on the left, you have typically a commercial center with a ductwork, metallic ductwork, non-insulated. And you can see that in this case, the acoustic issues we can be faced, so the sound we have to tackle, is really due to the vibration of the duct walls, which can radiate sound outside. So this is typically a question of sound insulation. And on the right, you have another practical case from Paris-Saclay University, where you can see behind the false ceiling another ductwork. And in this case also, you could say to yourself, okay, maybe in this case, sound insulation is not really a problem because I have the false ceiling. But as I told you, and as you can see on the picture on the right, you can see some space between the false ceiling. So I would say that from the acoustical point, it will not be able to insulate correctly. So typically the sound produced by the ductwork, even on the right picture, will be an issue and the question of sound insulation. The second challenge you have to address with ductwork is what I call be able to mitigate internal sources propagating along the duct. So the key rating for this issue will be the linear attenuation property, which we can measure. And the current solution you can find on the market are twofold. The first one, which is quite common, is to consider internal insulation based on open cell material, such as mineral wool or flexible elastomeric foam from our colleagues Cayman, for example. So basically what we are doing with this first solution, we are absorbing the sound by the insulation material. So basically the sound is propagating inside the duct, but thanks to the insulation, we are able to dissipate the sound from the source to the opening of the duct. The second very common solution we can mention is the metallic silencer, which can be combined at some point of the ductwork to provide some good linear attenuation property. So let's shift to another picture just to give you a practical realization of this. So in this commercial center, you can see that some sound is radiated by the duct opening. In this case, we are talking about a circular duct. But typically, in this case, we are talking about linear attenuation. And if you want to improve your acoustic in this big room, you will need some internal insulation or self-supporting duct. So now I'm going to leave the hand to my colleague, Elodie, please.
Thank you, Gary. So now that you had all the basics regarding acoustics, we will speak about the solution to reduce duct noise. First, we'll just do a step back regarding HVAC. So as you know, HVAC is all that deals with water and air flow in the buildings. Depending on your needs, there are different HVAC solutions. For instance, if you want to have thermal insulation of duct, so of airflow, then you can either have insulation material added on the external face of the duct or in the duct, or you can have self-supporting ducts, which are pre-insulated ducts that Guillermo will tell you about later on. If you have an issue regarding fire resistance, then there are some products that you can put out of the duct on the external face of the duct, which can help you to have up to 2-hour fire resistance. And the last example I will give you, the last application I will give you regarding HVAC is if you need to have insulation regarding pipe, so regarding water flow, then there are some all-in-one products such as the U-Protect pipe section alu, and here you can have the three properties, which are thermal insulation, sound insulation, and fire resistance. And this covers all the HVAC applications. Now let's go back to duct and noise. So as Gary told you, what's key in acoustic? What's key is really to be able to identify your needs, because depending on what you need, then the solution will be different. For instance, if you need to increase the speech intelligibility in a room, then you will need sound absorption. That's what happened in cinema. And to increase sound absorption in a room, then you need to add either panels or ceiling that have absorbing properties. If your need is to avoid sound transmission from one volume from one room to another room, then you will need sound insulation. And in this case, you will have to apply the rule, which is mass spring mass, to be able to really isolate the sound. And this is what you have in partition walls, for instance. Partition walls, you have the plasterboard, which is the mass. Then you have an insulating material, such as glass wool, and partition wall, which is the mass. So you have the mass spring with the insulation material and mass. And really, depending on what is your need, then there will be a type of solution, a type of insulation that will solve your need and that will help you to resolve your acoustic problem. If we now focus on duct, so there are three types of insulation that you can have. The first one is that you can put in the internal face of your metal duct some open porosity insulation material. This could be K-Sound or CLIMAVER. What's happening when you put some open porosity material, insulation material in a duct, then you will have both sound attenuation and sound absorption. On the other hand, if you do put your insulation material outside of the metallic duct, then you will only reach sound insulation, because in this case you will only have the mass and spring system. You will not have the absorption through the material. And there is a third solution, which will be explained by Guillermo.
Thank you, Elodie. Hello, everyone. So probably now you're seeing this slide and you're asking, what is CLIMAVER? So CLIMAVER is a self-supporting duct, okay, that is double phase. We, as you see in the image, you have an aluminum face outside, like acts as vapor barrier, okay, and internally we have a phono-absorbent material that allows to the product to give the best performance in acoustic that you will hear later during the presentation, okay? And how it works, you have a very simple board, and the way to manufacture the duct is just using very simple hand blades, okay? So making very simple cuts, you create the straight duct, and then you make different kind of cuts to create the different shapes. So coming back to the acoustics, okay, we are going to start with the sound insulation, okay, and the standard, international standard that we are going to follow is the 15665, okay, and the way to test is you have a loudspeaker outside the room, and you have a duct that is crossing the room, okay, and you have a microphone that is measuring the vibration of the duct, and you can compare what is the result with the different systems that you install in this room, okay. The higher insertion loss is better insulation. So as much as you can reduce the dBs is much better for the solution. So now I present you the systems that we tested. Okay, we have the CLIMAVER, that is an external insulation, as Elodie mentioned. Okay, we have the KaiFlex, elastomeric foam from Cayman. Okay, and CLIMAVER Netto, that is the self-supporting duct that I already present to you. Okay, with 25 millimeters. So now I recommend to you to put in a comfortable way the volume of your system, of your computer, okay, because we are going to hear some examples of the test, okay. For all the samples we have the same internal dimension, that is 300 by 300, okay, and we are going to check first how it sounds, the nude or bare metallic duct. Sounds like this. Now for the same speaker with the same internal dimensions, but now we are going to put the same bare metallic duct, but with CLIMAVER with 25 millimeters of thickness. Now we have the CLIMAVER, so we don't have any metal, okay? We just have the self-supporting duct, okay? And the noise that we are going to perceive in this test is like this. And for a CLIMAVER apta, that is the same configuration that CLIMAVER Neto, but with a higher density, so higher thickness, sorry, is 40 mm. So it sounds like this. And now, for you to remember how it sounds at the beginning, okay, with the bare metallic duct, I put the bare metallic duct acoustic audio. So what you can hear is that every insulation that you put around the metal duct is going to have an effect, okay, and you are going to have a reduction of the noise, okay. You see the graphs that we have in the left that they are doing by an external laboratory. We can achieve in the external insulation between 10 and 1 decrease of dBAs, and with the internal insulation we can have from 18 dBAs to 10 dBAs. So the key insulation properties that you have to take in account when you want to increase the insertion loss of the system or your HVAC system is the thickness. As much thickness you have, much better. Okay, you are going to increase the performance. Okay, the open porosity. If you have a facing that is open, is going to absorb more the noise and is going to decrease the noise that you are going to perceive outside. Okay, and the thickness of the product, because depending of the way of the system, is going to add more, as Elodie mentioned before. So that's all from insulation for insertion loss. Now Elodie is going to present us the linear attenuation.
Thank you, Guillermo. Okay, regarding linear attenuation, so it deals with sound absorption. We also did tests regarding the EN ISO 11691, and this was done with the loudspeaker and without flow. So what we did is that we measured the linear attenuation in bare metallic ducts, and we did measure linear attenuation with ducts with insulation or with CLIMAVER duct, self-supporting duct instead of a metallic duct, and we did calculate the sound reduction. At the end, the better the linear attenuation, the higher the linear attenuation, the better it is, and the better is the sound reduction. Okay, same as Guillermo, we did the test with the 300 per 300 internal section samples. So we had 2.4 meters bare metallic duct, and after we did the same with CLIMAVER, so it was 2.4 meter of metallic duct plus the external insulating material, and then we did it with CLIMAVER. So with our self-supporting duct, 2.4 meter of CLIMAVER with different thicknesses. So we'll start first with the bare metallic duct, and this is what you can have in the measuring room. So this is what you can have at the end of the duct, of the 2.4 meter duct. Okay, now what we did that we did add some CLIMAVER. So CLIMAVER, it's external insulation material that we put outside of the duct, and we did put 5 centimeters, 50 millimeters of CLIMAVER. So I will let you hear. Okay, I don't know if you did hear any difference, but we didn't measure any, because as it deals with linear attenuation, with sound absorption, as the insulation material is out of the duct, in fact, the noise is rebounding on the metallic duct within the duct, and it doesn't reach the insulation layer. So that's why there was no differences. Now, if we have the insulation material in contact with the airflow in the duct, like we have in CLIMAVER for CLIMAVER to Neto, here is what's going to happen. Okay, so I guess you did listen the difference. And now if we increase the thickness of CLIMAVER A2 Neto up to 40 meters, which is CLIMAVER A2 Hepta, then And this was only done on a straight duct of 2.4 meter of 30 per 30 centimeters internal section. If we go back to the bare metallic duct, just so you remember. Those are the curves. So we didn't put the CLIMAVER because they were flat. They were like the bare metallic ducts. Here you can have the curves of two insulation materials that you put inside, which were the CLIMLiner and the K-Sound. They were both of 25 millimeters. And you have also the red line, which is a red curve, which is CLIMAVER et Netto. And what you can see is that for all the three systems, you can have a linear attenuation over 20 dBA on only 2.4 meter. That is said more than 7 dBA per meter. And this was on the 30 per 30 centimeter ducts. If we now go to some shaped ducts, as you can understand and as you can guess, if you do have some shapes, then it's going to be even better. And in fact, that's what's going to happen. You have here the blue line, and the blue line at which is a reduction of 18 dBA. It's only the 2.4 meter of a straight duct. And if on this straight duct you do add a 90-degree elbow, then you have the black line, and you have a gap of plus, and you gain 10 dBA more. So with just one elbow of 30 per 30 centimeters internal section, then you can have a gain of 10 dBA in just one elbow. And of course, if you do decrease the internal section even more, which can happen with the shoe, that's what you have with the yellow line, then you can even increase it of 18 dBA. That is to say that with a linear duct of 2.4 meter plus a shoe of 415 per 20 centimeters, then you can reach only with this 36 dBA, which is quite a lot. So of course, in this case, the more shapes, the better it's going to be, and of course, the smaller the duct, the better it's going to be as well. And I will let Gary give you the conclusions.
Thank you, Elodie. So hello again, everyone. So now I will try to summarize a little bit what we have told you so far. So as you understood from Elodie and Guillermo, we have a wide range of HVAC solution able to provide you some acoustical benefits. And so, for example, if you consider on the left our external insulation, from the acoustic point, it will give you some sound insulation property depending on the thickness of the product and also the material properties in terms of stiffness, density, etc. But on the other hand, as you understood, since we are talking about external insulation, you will not be able to absorb the internal sources propagating inside the duct. So in other words, the linear attenuation will be low because the sound absorption in the internal walls of the duct will be very low. You will have lots of sound reflection. So typically in this case, you will be able to address sound insulation property, but to address the sound radiated by the duct openings, you will need probably some silencer, metallic silencers, which can be quite interesting, but can be a little bit quite expensive also. And now if you think about internal insulation and CLIMAVER product, this kind of solution will also provide you, as Guillermo told you, some sound insulation property, depending again on the thickness and facing and so on. But on the other side, it will also give you some linear attenuation since the internal wall of the duct will be absorbing. We are talking about open cell material. So in this case, you will be able to address both sound insulation, but also linear attenuation. And the practical consequence of this is that depending on the case scenario, in this case, with internal insulation or CLIMAVER self-supported system, silencer might not be always needed, I would say. It will depend on the practical case. So maybe I will finish on this on a practical example coming from our Thailand colleagues. who presented us quite recently a practical case where they tried to benchmark a realistic ductwork based either on CLIMAVER Netto 25 mm or a metallic silencer. And as you can see, we achieved, by using CLIMAVER Netto, quite interesting cost saving per month, but we also reduce the energy bill per unit of ductwork, simply because by using CLIMAVER Netto, you are able to decrease your energy consumption since you will have less static pressure. So this is just an example giving you some keywords and key facts on ductwork. Now I'm going to leave Guillermo finish.
Yes, and we are going to finish with the conclusions. Probably, if you are here with us listening this, is because you are aware about the problematic that we have sometimes with acoustics in our HVAC systems around the world. Okay, and the first important point is to identify what you need, what you are looking for. Okay, if you need insulation, acoustic insulation, if you need acoustic absorption, or maybe you need both. And depending on what you are looking for, you are going to need one kind of solution or another kind of solution. But the first and very important part is to identify your needs. Okay, and for sure, don't hesitate to contact us. Okay, for technical support, for the test reports, for experience, for any idea, whatever. Please don't hesitate to contact us, and we are going to be more than happy to answer and help to you in your acoustic issues. So now it's time for questions. So please feel free to make questions in the chat.
Okay, so first of all, thank you, Elodie, Guillermo, and Gary for this very clear presentation and webinar. I think we have understood that there are two different main issues in HVAC acoustics and HVAC ducts that we need to address in different ways. The first is the noise passing through the duct walls. The second is the noise propagating along the ducts to the ventilation outlet. The good news is we have also seen that we have the solutions. Noise is not something inevitable, but we have different solutions that can improve either the sound insulation or the linear attenuation of your ductworks. And now we are going to answer your questions in the chat. So let me check what we have here. Okay, 1 second. So first question was, of course, we're going to share the presentation and the replay of this webinar, so I can already answer this question. Then we have a question. What will be the effect on linear attenuation if we consider the airflow too? I don't know who wants to take this one.
I can do it if you want. I can start. It's a good question, I would say. But generally in building, for our typical duct section, the effect of the airflow is quite low on the acoustical linear attenuation property. Because the airflow is generally quite low. We are talking about the velocity of the airflow lower than 20 meters per second. So for this range of velocities, the effect of the flow is quite negligible.
Yes, if I can add, the traditional speed of a HVAC system is between 4 and 8 meters per second. So in this air speed, this is not going to affect to this point.
Okay, thank you. Next question. You mentioned that covering metallic ducts externally is not efficient to increase the linear attenuation. Which other options are possible to improve this linear attenuation? I think we saw this a little bit, but maybe you can just remind it, please. Yeah.
But for linear attenuation, what you need is really to have your wavelengths, so your sound in contact with the insulating material, with an insulating material which has open porosity or open cells. So in this case, either you take a metallic duct and you put inside an open porosity insulation material, so like glass wool or K-sound, if you take a FEF, or you can use CLIMAVER, as it has already its open porosity material is directly in contact with the sound.
Okay, thank you, Elodie. Another question is, what is the typical sound level of HVAC ductwork?
It's if I can.
Yeah, of course.
It's very open, this question, because it depends a lot of the project, of the system, the air handling unit, the quantity, the size of the machine. So it depends. Sometimes in some legislation what you can find is the last point levels that you have to achieve. So you don't care a lot about the beginning, but you care about what is going to be perceived by the final user. And that's the point that in some cases you need to achieve 35 dBs or 40 dBs, depending of the local legislation.
Maybe I can add, yeah, without any insulation, I would say at the duct opening, you can be faced to sound ranges from 45 dBA to 65 or even 70 dBA in practice, without any insulation.
And without any silencers.
And any silencers, of course.
Okay, thank you. One more question. Can you please advise on the precautions to be taken on the selection of an interior duct insulation material to prevent that with time it will get rotten and a potential source of air contamination?
Well, in fact, all the materials that we have, they are A+, and we know that we can clean them. So that's to say that we did pass the erosion test, and we made some cleaning tests with a French company, which is IGNR, and there was no erosion, there was no destruction or nothing. Nothing's happening to the insulation materials. So
Yes.
there is no worries.
We can say that what we make is we make 20 cycles of cleaning inside the duct, okay, with the clean liner or with the CLIMAVER, okay, and after that, after make the 20 cycles, that means one cleaning per year, for make you an idea, okay, so 20 years, and after that you make a fiber emission test, okay, so you measure at the end of the system what are the particles that you are receiving, and you have to achieve some level, and we are far away from the minimum required.
Far below.
Yeah.
And we did it with the conventional cleaning method. So rotating brush and the whipped and the pressurized air.
Okay, thank you. What are the benefits and or drawbacks of using silencers compared to the mineral wool products you presented?
Okay, the benefits of don't use silencer or reduce the size, it's obviously reduce the space that you are going to need in the room or in the place where you have the silencers, and as well you are going to reduce the pressure losses, okay, because as probably you know, the silencers are have a high impact in pressure losses. So if you can reduce the silencer size, or even you can skip the use of silencer, you are going to take this disadvantage. The disadvantage of maybe don't use silencer could be that in some frequencies the silencers are very effective, okay, and sometimes it's more difficult to achieve this performance in this kind of frequencies with other kind of products or insulation.
Maybe I can add a small comment regarding the low frequency range, because we know that silencer, especially the biggest one, with lots of baffles made of absorbing materials, they are able to absorb the low frequency range. And with our range of products, we also can imagine to have similar performances, for example, by introducing some kind of elbows or branches. So we have some optimization margin, I would say, even without silencer, to provide similar performances, even in the low frequency range.
And I guess you all know that in silencers, the insulation material that is in the silencer, it's mineral wool. So it's open porosity mineral wool.
Thank you. Next question, which kind of acoustic regulations are there for HVAC acoustics?
I think that I mentioned before in the previous question, but it's very local. It's very local. I cannot say one international one. Okay, what I can mention to you is that in some green labeling, like LEED, BREEAM, they have some limitation of acoustics as well. So, but it's very local. You can find different limitations, and even in the different kind of buildings. You can have different limitation in schools than in a cinema or in a mall. So it's a very open question. It depends on the country. It's very local.
Maybe we can mention the European regulation. For instance, in France and the Benelux markets, you have some regulation regarding equipment noise. And for instance, in these countries, you have to ensure that your ductwork will emit a sound with a global sound less than 30 dBA, just to give you an idea.
Okay, thank you. Here I have a question related to CLIMAVER. What is the time warranty for CLIMAVER?
Okay, the time warranty is a local, but at the end, what we can guarantee is that during the lifespan of the CLIMAVER is going to maintain their properties. Okay, so the warranty of use, for you to know, CLIMAVER has a long history, has more than 50 years now. So, and we have CLIMAVER installed around the world with more than 25 years in some cases, okay, and it is still working perfectly. So we can guarantee that the product is going to behave correctly for the lifespan of the building, or when the building is going to need renovation.
And that's true that CLIMAVER is a solution that is not that well known in Europe, except in Spain.
Yeah.
Because in Spain, it's more than 80% of your market share for duct. It's a lot. In fact, you don't have metal ducts almost in Spain.
Something for ventilation.
Okay, then we have a next question, which is quite interesting. I'm not totally sure that this is exactly our domain, but we can try. So I would like to know if you have any relevant experience with flexible air ducts, mainly installed in houses for mechanical ventilation with heat recovery. What should we do if we have problem with noise there? Is it mainly the unit's fans? I think so, but what do you think?
Well, the issue is if you have issues with that, I'm not sure there are some. Well, there are some flexible ducts that are pre-insulated, but the internal face is aluminium, so no linear attenuation.
And what I can mention is that in some countries you have a limitation of length of this flexible duct. Okay, so for example, in some European countries you have a maximum of 1.4 meters length that you can install for flexible ducts. Why? Because it's very acoustic. It's very bad in acoustics, and as well it's very bad in pressure losses. Yeah. So it's going to increase the consumption of energy a lot.
Okay, I'm just checking here. This one I think was already answered. I repeated, but I think it was already answered. How is the procedure to clean the interior of CLIMAVER ducts? Can we use a brush? I think you said it.
Yes, it's possible to use a brush and as well compressor. Okay. What is not possible to use for cleaning in CLIMAVER is liquids. Okay, because it's porous, so it's going to be absorbed.
Yeah, but all the other traditional way to clean duct, metallic duct, you can use it.
Okay, one more question. Is there any fiber erosion in case of inside insulation?
Well, that depends on your liner. That's why we made some tests. So for CLIMAVER and for ClimLiner Slab Clean Tech, then we know that there is a tissue, a fabric that is tough enough to be clean without being eroded, without erosion or without releasing some fibers. But that's true that if you have some glass veil or something very fragile, then with a rotating brush you can destroy it. So that's why you really need to be careful of the insulating material you will put in your ducts.
And for sure, we have the test to be sharing if you have doubts or you want to check that everything is correct.
Exactly. Okay. Next question, which softwares are available to do acoustic predictions on ductwork?
Okay, we have one, internal for CLIMAVER, special for CLIMAVER, where we are measuring the linear attenuation following the Sabin formula. That Gary can tell you more if you want, if you ask. Okay, and it's a method very, very useful because you can check what is the difference in the same system with CLIMAVER and with other solution, with PIR or with metal duct. Okay, so you can check at the end in the grills and the diffusor what are the dBAs that you are going to achieve and compare with metal, and then you decide. if it's okay for your system or not, and even you can check if you can reduce the size of the silencer or even skip the silencer. As well, I know that in Revit as well you can find some packages of acoustics that you can use to measure the acoustics as well.
Mm-hmm. And if you need some acoustic data, well, we can share our trial reports and our data. And as you've seen for linear attenuation, CLIMAVER and CLIMAVER, they are quite close. So if you don't have CLIMAVER in your acoustical software, then you can have an idea of what you could have with CLIMAVER.
And just to finish, I would say that we have some internal tools to predict linear attenuation, so sound radiated by duct openings. But to my knowledge, we do not have such a tool to predict the sound insulation of ductwork.
As well, about sound insulation, what we have is DB station that you can check it. Okay, that is a web page where you can put and make a simulation of how a real building, what is the perception of the acoustics. Okay, and with different solutions, you can perceive what is the result and how good or how bad is the insulation that you are selecting.
Thank you. One more question. In case we use elastomeric inside insulation, will there be any smell?
They should not be, but if you do use it inside, then you should take some elastomeric foam with open porosity, not with the closed porosity. Because in this case, if it's closed porosity, you will not have the linear attenuation, but you should not have any smell.
In the case that you have any smell, is because it's something wrong, okay? But it's not something that must happen. So.
Okay. How about the linear pressure drop of the internal facing itself when comparing to metallic ducts?
We've done some tests, and in fact, what we measured, so we measured the pressure drop of straight duct and of shaped duct, and when we did compare it to the standard for metallic duct, we were a bit below. So what we say in France is that you can do the dimensioning of your CLIMAVER or of CLIMLiner as you are doing the dimensioning for metallic ducts.
And the reason of that, okay, is that you have to think that the airspeed in the HVAC units are not very big. Okay, as I mentioned before, it's between 4 and 8. And in this part of the gap of the velocity, air velocity, the difference in pressure losses between metal and CLIMAVER or CLIMLiner are very, very few, are almost equal. Okay, for sure, if you go to 40 meters per second or for 550 or 60, the difference is very big because it's exponential. But at the beginning, when the speed is very, very low, the differences in pressure losses are almost nothing.
Yeah. And in fact, we did it until 18 meters per second, and we were still below. But we never go up to 18. As Guillermo said, usually we're more around 2, 4, 8, never more.
Okay, I think we can take one last question. What is the maximum air speed recommended for CLIMAVER?
It's
18.
18 meters per second.
18 meters per second.
This is the maximum. Okay.
And in fact, we did all our tests with the 18 meters per second. So pressure drop and erosion, it's all 18 meters per second, but it's way higher than what we use. What you use as well, what is conventionally used.
Okay, I think we have answered most of the questions, so it's time now to conclude this webinar. For more information, you can visit our website or our LinkedIn page. Don't hesitate to subscribe to our LinkedIn page also. Or if you would like to dig into other technical insulation related topics, you can also review our previous webinars on our website. As stated earlier, the replay and the presentation of this webinar will be shared by email with all subscribers to this webinar. And I would like to thank again Elodie, Guillermo, and Gary for sharing your expert insight with us. Thanks a lot to all the participants for your active listening and for your numerous questions. So we hope to see you in our next webinar. Thanks a lot.
Thank you.
Thank you.